What's up, guys? Welcome to our final video here from the Mathnasium. It's been a long time. We've been in seclusion, and I'm going to end with a kind of a fun one, fairly simple. We're going to learn about push buttons in digital electronics and how you can use them in the variety of ways that you can use them with an Arduino. So you guys probably have seen the push button. There are many kinds of push buttons, and it's as simple as it's just a switch. I'm going to show you how it works, and we'll start by kind of drawing out what's going on inside the button. So I'm going to draw this extra large, but basically you've got a button like so, and the button has a little plunger like this, and you'll see 4 pins coming out. Now, when I first saw this, I was a little confused because it's like 4 pins. Isn't a switch just you have electricity coming in, then you press it and you have electricity coming out? Yes, it is. But with digital electronics, there are some advantages to having extra ones, and I'll show you why here in just a second. So what's going on the inside? So when that button is not pressed, basically what you got going on. Let's make a copy here. So here's what it looks like when it is pressed. So let's say not pressed. Not pressed, let's do in purple. So for not pressed, the button on the inside, you got your 4 legs coming out. Those go into the holes on your breadboard, like so. And then these are actually connected across, and these are connected across. So you could actually use these legs like wires traveling through your push button. Where the push button does, or what it does, is rather when you press down, it bridges between these 2 positions. So pressing, not press is going to look like that. So as electricity can flow across these pins, it cannot, however, cross. So when it is pressed, it looks more like this. So this is closed. You have a closed loop. So if you have this as a positive, you can send basically electricity to 3 different locations simultaneously, which is pretty cool. But that's not really why you use it. You don't use it to send it 3 different places necessarily. We're going to go over kind of how that works and what you might use it for. Let's pull up Tinkercad and take a gander, shall we? So, let's use this for its most basic form. So push button used in its most basic form is to just, you can cut the flow of electricity like a switch. So let's do that first and test and make sure that that makes sense for us. I'm going to pull up Tinkercad, and I've got a little LED here. We're going to drag in a resistor. Okay, we'll make it 330 ohms, send it to ground. Just like that. And I'm going to drag in a push button. All right, and rotate. Push button. Come in over here. Oops. And so what we're going to do is we're going to have this be the negative end of the circuit for the LED, and then we're going to have the positive end be this side, but it's going to come out of one of these ports. So let's go ahead and actually let's just send it from the 5 volt, so we have kind of constant flow of electricity. So it's coming in, and it's gonna bridge the gap between these wires. So it's going to come in, and then electricity is going to be flowing into this automatically if I press the button. So like, notice how I said this crosses here. So if I were to run this to right here and start the simulation, the light will be always on, and when I press the button, it doesn't do anything. So if you're thinking I just can bridge across here, no, because that's already connected. So in order to get the light to blink while it's pressed, I have to connect to either to this one or to this one, because that is separated by this gap right here. So I'm going to send that up, start my simulation. I can now press to illuminate the light with the push button, which is pretty cool. This is a lot cooler on an actual Arduino board where you can, press more than one at the same time. I don't think that's possible on a computer, unfortunately. So that's the first way, is to directly control a circuit with the flow of electricity present. So I'm not controlling a port here. I'm just supplying constant voltage to this pin, and I'm closing the gate to send voltage to the LED. That's a cool way to use a switch for sure, or a push button. I'm going to show you another way though that's even cooler and a little more customizable, I would say. So another way to control a switch or control a circuit is you can have it read from the circuit. So way one we just did. The next way is to use digital read. Okay, and digital read kind of what it does is it looks at kind of the voltage of the circuit, and it can kind of spit back several values. So it can be connected, for example, to the positive side of the circuit. It could be connected, which would be like the on or the whatever, 5 volts, you know. It can be the positive. It can be connected to, so these are kind of our 3 options. It can be connected to the negative side of the circuit, which is like off or ground. Okay, and the third state is, or we'd call this a 1 and this a 0. The third state it can be is when it's not connected to either, or it doesn't know which one it's supposed to be connected to. If it's not clear, it goes into this state where it's kind of erratic and can kind of take on both values. And this state is not, it's something that can cause issues. We're not going to worry about it too much, and I actually don't know a whole lot about it or why it's happening. But we're just going to worry about these two and kind of how we can structure our circuit to control, to make decisions based on if the button is pressed. So what we did before is we physically controlled the circuit with the button, and that's not what we're doing now. What we're going to do now is we are going to read the button with digital read, which is something new, okay? And then we're going to use that to kind of make a decision on whether or not to turn the light on or off. But you can use the push button to do lots of things in your code. So like if the button is pressed, you can have it run a certain basically a certain like light show that you have on your Arduino. And if a different button is pressed, you can have that represent something else completely. Okay, so this is really cool. We can make some really cool decisions with button pressing. All right, so don't worry about state 3. That's out of the scope of this course. We're going to worry about these two, and I'm going to show you how to set that up. So the first thing that you got to do, I'm going to try and do this correctly. Now you want to use, I think it's a 10 kilo ohm resistor. I'll just use a 1 kilo ohm is fine too for this, and you're going to send that to ground. So what we're doing is we have this path through the circuit, and we're going to open up the circuit when we run our simulation. So when I press this button, it's going to allow the flow of electricity through from 5 volt into ground. So what we do now is on our Arduino, we're going to find another pin. I'll just use like pin 8 or 9, it doesn't actually matter. And I'm going to run this in up to here, and I'm going to connect it down to any of these pins or any of these pins over here. It doesn't actually matter, and it's hard because I don't want to pivot on exact points because then it looks like it's plugged in elsewhere. So I'm going to connect it to right here, and I'm going to show you what happens. We'll go to my code. Text. Okay, so what I want to do is when I press the button, I want it to turn this light on, but we are actually going to be controlling kind of a different circuit to do that, which is a little weird. So I'm going to plug the LED into pin 13. So now this is going to be how we turn the light on. So it's going to come out of here, up through the LED, and then back to ground. Okay, so that's my pin mode for 13. And so now we need to say how we are using port 9. We're using that as an input. So we say pin mode for port 9 input in parentheses. Okay, and then when do we want this light to be turned on. We only want it to be turned on if the button is being pressed. So how do we say if the button is being pressed? Well, we're going to use a conditional. We'll say if. Now we need this new variable. And I'm going to call this just button state. This is a classic one for us to use. Button state, and the button state is equal to digital read. And then you select the pin that you're going to be reading from, which is pin 9. Okay. If button state, okay, so basically it's going to kick back which side of the circuit you're connected to, and if you're not connected, right, this is kind of not connected to either side, it's going to be wonky and kind of unpredictable. So not connected, this is kind of a cautionary spot to be in, and you got to be pretty careful that you don't do this, or your program's not going to behave correctly. So you want to be directly connected to either positive or negative, and it's got to be clear as to the path of the electricity and where it's flowing. So, and we're taking a look here. So we can say if button state, okay, is equal to. So we double equals to check and see if it's equal to. If it's equal to, we can say plus on 5 volts 1. We can also say high or low. I'm just going to say 1 because 1 means it's connected to the positive side, 0 negative. I'm going to put in my brackets. Okay, so if it is connected to the positive side, which means, we'll go over that in just a sec. If it's connected to the positive side, we're going to turn it on. And if it's not connected to the positive side, we're going to turn it off. And we can do that in two ways. So we can say, if it's not connected to the positive side, we could say if button state equals 0, or you can just say else, because it can either be 1 or 0. And else covers every other scenario. Okay, so I'm going to come down here. So remember, we're turning on port 13. That's our LED. So we're using port 9 to make a decision. We're reading port 9, and we're storing the value, either a 1 or a 0 in button state. And we need to declare that it is an integer. So 1, again, means that it's connected to positive or on, and 0 represents negative here. So when I run this program, we're going to talk about why this works. Okay, when I press this button, the light illuminates. Okay, so here's what's happening in this particular circuit. This wire to port 9 is checking to see kind of what's happening within the circuit. And you can't just plug it in anywhere, and I'm going to try and explain why. This resistor here is super important, and in fact, if you delete this resistor and connect it to ground and start your simulation, press the button, the light doesn't illuminate. Okay, it won't work. The resistor is key, and here is why. Let me go back. When I have this connected to a resistor, the flow of electricity is coming, really, it's coming, through the positive here. It's not bridging the gap, but the electricity from port 9, it's detecting that this is actually connected to ground. So it's reading the circuit and it's saying, hey, look, port 9 is connected to ground. It's directly connected to ground, okay? But it's connected to ground through a resistor. So it's still connected. It's still saying, hey, I can tell that I'm connected to ground when I start the simulation. But when I press this button, we have a kind of a problem, right? It's connected simultaneously to ground through the resistor, but if I go this direction, it's also connected to the 5 volt, the constant 5 volts. Okay, so that means it's connected this way and it's connected that way. Well, electricity is always going to take the path of kind of least resistance here. So if it's flowing out of this port, right, and coming across, it's going to, since there's a resistor here, it's going to redirect, some of those electrons into port 9, which is going to see this as reading high. Okay, so it's going to see that, because otherwise, if the resistance is not there, it's just all the electrons are gonna go to ground, right? If it is there, it's saying, whoa, hold up. Electricity is going to take the path of least resistance, which means it's going to send it down through port 9, and that's going to be reading as high or on. And so when the button is pressed, electrons are now flowing into port 9. It's reading that as high. When it's not being pressed, there's no electrons flowing through here, and it's detecting that it's connected to ground. Hopefully I did a good job of explaining that. There's a lot of complicated stuff going on here. So now we're able to then, when I press the button state becomes 1, and it will turn it on. And when I let go, the button state becomes 0, and it will turn that light off, the LED off. So that is the basic idea behind how these work. And what I want you to do for your assignment, so think about this. So when you press this button, you can have it run, not just turn on a light, but you can have it run a whole series of commands with delays and a bunch of things that last for seconds or minutes. So you could press the button and then have your Arduino do lots of different things. So what I want you to do is I want you to create a circuit that will use multiple, at least 3 push buttons connected to different pins as inputs. And you're going to, when you press each button, it's going to do something different inside the program. And I want you to use those, with if statements and making a decision. So you're going to have basically, you're going to have to create 3 variables. So you might have like a button 1. So in your program, you're going to have, the only thing that's different, you'll have more pins, and you're going to have a button 1 state, right? And then when button 1 is pressed, do this, else do that. And when button 2 is pressed, do this, else do that. So you have multiple if statements. You'll have multiple definitions. You're going to read from different ports on those button states and have your Arduino do 3 different things. Thanks for watching, guys. This is the final video. If you have not gotten a chance to submit on my class website, the teacher feedback form, that would be great. It's been real. It's been one heck of a year. This is our last full week, and I really wish I could see you guys in person. So, yeah. We'll talk to you soon. Shoot me an email. Don't be a stranger. If not, we'll see you as soon as we can. Okay? Have a good one. Later.